Black holes. The last phase after a supernova or star explosion for highly massive stars is the black hole, for which the core is enormously heavy and its elements start fusing into iron that no longer releases energy. The heavy iron core keeps compressing, forming an infinitely dense core or center and tiny core where the mass is concentrated, too much heat, enormous energy, with an outstanding gravitational pull that swallows every surrounding object and even light. Of course, you also have an outer shell that, due to this recession of the core, it had escaped the gravity, so it starts pulling outward. This is the expanding atmosphere and material surrounding that will be shed and becomes part of the nebula when the core explodes. Okay? Actually, even before the explosion, or this might be for smaller stars. Still, here also the case might be this, that you have an outer shell that would be shed as the core is being compressed. Also, only objects that are fast enough and travel at a safe distance from the core can escape being devoured. This is the outer shell. That would be the material and objects that start becoming detached from the core and are no longer swallowed up. Okay, so they have escaped the gravitational pull. That's why, since this core is receding, is being compressed, okay, so the mass is being concentrated in the innermost part of this core. That's why the outer shell starts detaching from this gravity and starts expanding outwardly. Now, after the explosion, the perimeter around the black hole, after which a traveling object cannot escape the gravity or gravitational pull, is called the event horizon. And the dense core at the center is called singularity, where you have an infinitely dense core, almost to a point, okay, concentrated on a point, very pontified, where there is enormous gravity, enormous energy, enormous mass concentrated at that singular point with enormous, outstanding gravitational force. Let's observe the geometric outlook and structure of a black hole. Again, you have the singularity, which is the core of a black hole that has been squeezed infinitely, where you have a very large density, a concentration of mass, and almost an unbelievable gravity that can even swallow up light. You have the event horizon, which would be the circumference around the black hole, after which an object can no longer escape the gravitational pull and is consumed or devoured by the gravity. It's swallowed into the center. Then you have the accretion disk, which is the hot glowing gas and dust spiraling down into the black hole toward the center. These are the different gases and different dust particles that are being swallowed into the center of the gravity. And the jets are narrow beams of particles ejected at near light speeds from the disk center. A common naming for the jet would be Hawking radiation, okay, that we're gonna talk about later. How the ions that are circulating around the black hole, they create, because they are charged gases, they create like a current, just like an electrical current. And this shifting electrical current would also create an electromagnetic wave due to the electromagnetic phenomena, okay? So the current induces or creates a magnetic field around it. So since this electromagnetic field, since this current is of a high energy, a very high frequency as well, so it creates high frequency energy electromagnetic beam, just like a beam of light, except that would be in the range of the X-ray frequencies or ultraviolet frequencies due to the high frequency of rotation around. Black hole mass. The mass of a black hole can range from hundreds to hundreds power the mass of the sun. Theoretically, it can have also a miniature atomic mass in CERN particle accelerator, where they are conducing, they are running the same types of experiments of colliding protons with antiprotons to tear down the fabric, the time-space fabric, and creating a black hole, just like what a supernova does at the end of the star life cycle phase. So how are they detected? First of all, you have the bending of light from stars nearby. So the stars near the black hole would have their light waves, their light beams bending, behind or around a black hole, creating a phenomenon called gravitational lensing, which takes the form of distorted light imprints. So when we are observing galaxies and stars, you would see the star on the telescope in a distorted shape. This is called gravitational lensing due to the bending of the light curves. It's like having a lens, a glass lens, that will distort the shape of the objects being visible from behind it when it is a convex or concave lens. So the same phenomena is happening here. Second, you would have a detection of X-rays that are coming from the material circulating around the accretion disk. Third, the gravitational ripples or gravitational waves from black hole mergers, which are ripples in the space-time fabric caused by the acceleration of space objects going around a black hole. It is similar to the waves traveling across a pond after a rock hits the water. Now, a closer analogy for that would be if we consider a blanket, and you place a metallic ball on the blanket. So the blanket would be stretched where the ball is sitting. Now, as the ball is traveling on this blanket, the parts that have been stretched in the proximity would be released as this ball of gravity, so to speak, travels further. So you have a rebounding of the stretch of the time-space fabric. By the way, it was intentionally called time-space fabric, even mentioned in the Bible that God will fold back this universe like a garment and get rid of it. Another word for garment is fabric. Why is that? Because, it stretches and then compresses, just like a tissue. Just like your t-shirt, if you stretch it, the same stretch will incur equivalent distancing, equivalent gap for different consecutive points on this tissue. And as you release it, everything will go back into place. The same thing for gravity. The gravity would pull the matter, stretching it in a specific direction. But once this gravitational force has become a little bit, has furthered away from this spot, this same fabric, this same matter that were stretched away from each other would rebound back into its original position, which would create the ripple or gravitational waves commonly determined. So gravitational waves, simply put, in a neutron binary star event or a merger event, where you have two black holes together, merging together, in which two black holes are colliding against each other. So they spin at a very high velocity, and given that they have a massive weight, they attract the matter of the space as they get closer to one side, and then they release it as they get further to the other side, creating a tidal wave, a push-pull, just like a spring motion, by the way. This tidal wave travels into the time-space fabric, creating a ripple effect across space, just like a stone creates a ripple across a pond. But this also distorts the time element, the time parameter or factor is distorted. So you have a dilation of time or a compression of time as well. Even they will perish, but you endure. Yes, all of them will wear out like a garment, you see? Like clothing, you will change them and they shall be changed. This is Psalm 102:26. Black hole characteristics. The speed by which a black hole spins is defined by the following formula. J is the angular momentum, C is the speed of light, G is the gravity constant or gravitational constant, and M is the mass of the black hole. J, which is the angular momentum, is given by I times W, whose I is the inertial momentum and W is the angular velocity. Or in other words, how many radians is the object rotating around the black hole, okay, or the black hole itself, okay, that's the spin of the black hole, I'm sorry. So how much radians it is rotating per second. Now J, which is the angular momentum, is given also by RMV. R is the radius, M is the mass, and V is the tangential velocity. Now A star, which is the spin parameter and it is dimensionless, is given by JC divided by GM squared. J, of course, again is the angular momentum. C is the speed of light divided by G, gravitational constant, multiplied by M squared, which is again the mass of the black hole. Let's get the escape velocity or minimum velocity required by an astral object to evade being sucked inside the black hole. The object traveling near the event horizon has to have enough kinetic energy, which is produced by the motion, the speed, right? That is at least equal to the gravitational potential energy in order for it to escape the suction from a black hole. Okay, so let's lay it out. So E potential, which is the potential energy, is given by the force of gravitation, gravitational force, multiplied by h, which is the height or the altitude from the center of the black hole, which is the Schwarzschild radius, by the way. Not Schwarzschild, not yet. It is the radius of rotation around the black hole. So E potential is given by G times M. Capital M, lowercase m, is the object traveling around the black hole. Capital M is the mass of the black hole itself, divided by r squared. This is the gravitational force here, multiplied by h, which is the altitude from the center, or the radius of rotation, which is r. Kinetic energy is equal to 1/2 mv squared, with m is the mass of the object rotating around the black hole, and v is the tangential velocity. Now, as a reminder, the potential energy is equal to gmm divided by r squared times r, which is g lowercase m, capital M divided by r after reduction. So the kinetic energy should be equal to the potential energy for this object to keep moving without being sucked by the gravity, to at least guard a state of equilibrium. So we are about to measure the minimum velocity that would guarantee that this object will remain at least around the event horizon without the risk of being sucked by the black hole. So as we place these two formulas together, we have 1/2 mv squared is equal to g lowercase m capital M divided by r. M is also deducted, so we get V is equal to square root of 2gm divided by rs, with rs is the Schwarzschild radius, which is, in other words, the minimum, okay, or the maximum distance that we can get close to a black hole center, after which there's no going back. This is the Schwarzschild radius. In other words, this is the radius of the event horizon zone. Now, one of the most common questions would be, why does a black hole or a binary neutron star having two stars rotating around each other produce radiation, what is called commonly as a Hawking radiation, correct? Let's talk about pulsars. A pulsar is a neutron star that rotates very rapidly, emitting a beam of electromagnetic radiation, usually radio waves and X-rays or gamma rays from its pole. And this, by the way, depends on the frequency of rotation and the speed of rotation of the ionized gas around the center, because this speed would determine the frequency of the current. That in its turn would determine the frequency of the electromagnetic wave, which becomes either X-rays, gamma rays, or radio waves that would be detected on Earth. So how does that emission take place? According to Coulomb's law, a conductor through which passes an electrical current will radiate an electromagnetic field having the same characteristics or properties as the source current, as the electrical current. Okay, so that would be characteristics such as frequency and wavelengths of the current acting as an antenna or circulating a conductor that is acting as an antenna. And the direction or like the sense or orientation of rotation will follow the same pattern of a screwdriver. So let's say it's rotating this way, the current is rotating this way, it will go in this direction inwardly. That would be the heading of the magnetic field, and vice versa. If the current is rotating like that, the field would be coming outwardly. In other words, the field vectors will rotate clockwise as the current is moving inwardly, and vice versa. Oh, and by the way, if we're talking about the current rotating clockwise, the field would move, that would be the one moving inwardly. So I might have flipped it here, but it still applies. So of course, we note here that since the electrical current has a low frequency, okay, let's say it's rotating around a circular conductor, the electromagnetic wave being generated, having the same frequency as the electrical current itself, won't be visible to the eyes. But it's still there, it's still detectable, which is not the case for the pulsars, where we can have like a gamma ray that is visible, clearly visible. Actually, not necessarily within the visual range, but still you can detect it as well. So by following the same pattern, the current, which is a flow of electrons around the pulsar, is generated due to the rapid rotation of ionized gases that are charged. Actually, this is due mainly to the rapid rotation of the star around its center, dragging with it, a mixture of ionized particles and electrons that actually generate such current. This current is of a high speed frequency, which I personally believe that it will produce a radiation of the same frequency of rotation around the center. Okay, so let's say the period is 2 seconds of rotation. From the period 1/2, you would get the frequency. This is my own projection here. So the same frequency projecting from the pole of the star would be the same frequency of the radiated wave. If we evaluate the period of the wavelength, which is the inverse of the frequency 1/f, we get the rotation period of the electron around the center of the star, or the ionized gas. In other words, it is the time it takes the electron to complete one cycle, one rotation. But this is just my own perspective, my own personal outlook over what's happening. It might not necessarily be as accurate. Okay? The magnetic field gathering around the atmospheric ring will project from the center outwardly, as we see here in the sketch. And since it's a high frequency electromagnetic field, in some instances, it falls in the range of visible light. Okay? It can be either radio waves, X-ray, ultraviolet, gamma radiation, etc. So we see here, this is how, in the same manner, just like this conductor here has a current flowing clockwise, we'll have the electromagnetic field projecting inwardly, like the screwdriver method, by the way. And in the same manner, you would get the radiation coming out from the black hole. A quasar is supermassive black hole feeding on nearby gas and dust, which gives them an extreme brightness and excessive energy. The gas and dust swallowed in heat up due to friction and the gravitational forces. The ionization and the flowing electrons released because of it result in the expulsion of a jet of visible light, like the electromagnetic wave generation. Okay, electromagnetic field generation due to the flow of a current, which would be ionization current. So because of it, you have an expulsion of a jet of visible light, ultraviolet light, and X-rays.